Hello and welcome to another video from Berkshire Guitar Amplifier Repairs in Reading, England. We're currently experiencing our false spring. We have our winter, then we have a false spring where we think it's spring, then we have our second winter, then we have the spring of hope where we think it's spring again but it isn't, then we have our third winter, and then we have a couple of weeks of spring. So it's freezing cold outside, and but the daffodils are blooming, so that's good fun. On the bench we have a Fender Blues Junior. You've seen these before. It's an amplifier I see quite a lot of. Not because it's particularly a faulty amplifier, it's just a very popular amplifier and a very nice amplifier. I do recommend this amp if you're looking for a small, nice sounding amp. However, I think we've got a bit of a job on our hands today because the customer says this started making very loud crackling noise, and when he looked in the back he could see sparks, and then he smelt smoke, and then the thing died. I've turned it on and it blows a fuse immediately, so there's a fairly serious problem with this amp. I warn you now, I think this is going to be quite a long video as I track down the problem on the amp, and hopefully I can fix it. So let's get it turned around, get the back off, and have a look inside first of all to see if I can see anything that's obviously burned out. We may get lucky, we may not. So I'll see you in a moment. Well, here we are on the inside of the amplifier, typical Fender Blues Junior. I've had a fairly good look around the board, and I think you'll agree with me there's nothing obvious there. What happens is if you replace the fuse here, this is a 1 amp quick blow fuse, as soon as you turn it on that fuse pops. Replace it and it pops again. I'll show you where that fuse is on the schematic in a moment, but it's on the primary side of the mains transformer basically, so something's pulling too much current. I've also pulled the valves on this amp, and it still pops the fuse, but I think you'll be interested to see. Here's one of the power valves I pulled, groove tube, standard EL84, and here's the second one, and I think you can see there's a big difference between them. This is showing signs of overheating and getting very hot. So I'm wondering if something has gone on here. The customer says that he heard a very loud crackling, and he said he smelled smoke, and then the fuse popped, it just went dead. So I'm wondering if this valve has gone down. So I'm kind of thinking HT might be a problem. What we want to do then is to get involved in doing some fairly quick measurements, and I think the first thing I'm going to do is to check these capacitors here to make sure none of them are short circuit, but I don't believe they are. They look fairly new. This amp is only 3 years old, so I'd be very surprised if they're showing these signs of problems. I'll also check the 4 HT diodes which are here. They'll be fairly easy to check, and again, I don't really suspect any problems there, although it's possible. Then I think what I'll do is I probably will pull these are the HT leads here from the mains transformer. I'll pull those and see if the fuse pops. I'm pretty sure it won't. So there's a few things we can be getting on with there. Let's do that and then see if we can slowly start to track down what's wrong with this amp. I have a feeling it's not going to be something trivial on this. I don't know why, just a gut feeling. Right, I'm just going to quickly check a few resistances on capacitors. I'm not at all hopeful here. I'm pretty sure these caps will be okay, but I'll go onto here, and yeah, that's kind of open circuit, and these will all be fine. 2K, 10K, they're charging up, of course. I kind of know it's not these because there's a 2.2k resistor in series after this before it feeds these, and it's that resistor there actually, and that is 2.2k. I've already had a quick look at that. I cheated. Let's just go on there again if we can. There it is, 2.14k. So you know, even if the other side of that was short circuit, it wouldn't cause all this huge current to come and blow the fuse. So I'm happy kind of downstream on the HT. This cap's okay. I thought it would be. What I'm going to do now is to go on to the B plus side of this capacitor, and this is the HT basically here, and with the valves out, all that feeds is the center tap of the output transformer, and so that should actually be open circuit. Let me have a quick check about that to ground. Obviously if that had some, you know, low resistance to ground, we know that's why the fuse is blowing. Ah, that's interesting. So on the B plus, which is here, we've got 74 ohms to ground, so there's a serious problem there. That should be open circuit. Let me, if I can, quickly show you on the schematic. Okay, here's the schematic. I hope it's close enough and steady enough for you. Here's the fuse that's blowing on the primary side of the transformer. Here's the HT winding. It goes through a bridge rectifier, through that capacitor that we were checking wasn't short circuit. I hope you can see that if that capacitor was short circuit, then this would account for the high current blowing the fuse, but it wasn't short circuit. However, on this side here, on this B plus of this capacitor, we've got 75 ohms or something to ground. Now that's it. That first of all, that eliminates everything look downstream here. Remember I said that we've got this 2k2 resistor feeding this capacitor, and then another 10k resistor feeding this capacitor, and we've got this kind of daisy chain of capacitors, and these are all high resistances. So we haven't got 75 ohms going out that way, and we know that's not short circuit, so it's got to be something on the B plus side. I checked the diodes, by the way, and they're all okay. Right, so it's something on the B plus side, but there's nothing on the B plus side because we've pulled the valves. Let me show you that part of the circuit. So it's a bit of a mystery this at the moment. Okay, here we are. Here's the B plus here. It just comes into the center tap of the transformer, look, and it goes round. The output valves are down here, so this goes off to the plates of the output valves, the two EL84s. But also I have noticed this, look, there are these two diodes, D11 and D12. Now this is positive, of course, and that's negative, so no current can normally flow through that diode that way. I think they're there to protect against flyback voltages or something. I'm never quite sure what they're for, but anyway, if this is positive, no current will flow down here. Current flows through the diode this way. So I suppose if one of those diodes was a short circuit or something, that would also cause our problems, because our resistance to ground, from B plus to ground, is about 75 ohms, and that's not far off a winding of a transformer. I don't know exactly what these are, but it won't be far off that, I wouldn't have thought. And so if this diode was short circuit, or that diode was short circuit, or both or something, we would have the solution to our problem. Why have they gone short circuit if they have? I don't know. Maybe the valve arced across or something and caused a huge rush of current through those diodes. I have no idea. Anyway, let's see if we can locate those diodes. Not quite sure exactly where they are. Let me have a look and then I'll show you where they are. Right, here are the two diodes here. It's D12 and D11. And I can immediately see that I don't like the look of this one at all. You can see it looks sort of fairly burned around there. How close can I get with this? Have a look. Yeah, you can see it kind of looks a bit burned around there, whereas this one looks not too bad. I think I can also see a split in the body of this diode. I'm just going to get my eyeglass out and have a look, and if I see that I'll confirm that back to you. You might not be able to see that. I'll have a look. I've had the eyeglass out and had a look, and there's definitely a split right the way down the body of this diode where I'm drawing the scalpel down there. I'll give you a chance to have a look at that. You may not be able to see it. Either way, that's not looking good, so we will need to change out both of those diodes. Unfortunately, that's easier said than done on the Fender Blues Junior. I've had a look at the schematic, and the diode is an R3000, and it's a suppressor voltage diode aimed to eliminate the flyback voltages which can occur sometimes. But the important take home here is that it's 3 kV, in other words 3000 volts, hence the R3000, at 0.2 of an amp at 200 milliamps. That's all I need to know. I can get any diode that's 3 kV and 200 milliamps or more to change these with. Ooh, look what I found in my diode drawer. I've obviously been here before, maybe I have changed some of these. I've got a whole load of these, 3 kV, it says 250 milliamps, and it actually says R3000, so we actually have the diodes in stock, which is brilliant. What I think I'm going to do actually is to just get in there. I won't do it now live on camera, but I'll show you what I do. I'm going to get in here with a pair of cutters and just literally cut these. I'm just going to cut the legs of these, bump, bump, like that, and see if that problem having this 75 ohms or whatever from the HT to ground, see if that goes away. So let me do that now and report back to you. Well, that sorted it. I cut those two diode leads there, they're now all floating, and now if I go between ground and RB+, I can do that without getting in your way. You can see that it's open circuit, which is exactly what we'd like. And I'll also show you something interesting. I have to get the camera a bit closer, but when you see the state of this diode here, you'll see we were definitely on the right track. No doubt in our minds there, I think you'll agree. Look, diode is completely burnt out, horrible burning residue there. That was the smoke and the horrible burning smell that the customer experienced. My guess is that the power valve went down and took at least this diode out. I'll just replace both, they're only pennies out with it, and if we replace those we should be in good shape. I might have a look to see if it is possible to do from the top. Let me explain what I mean by that. We just cut them out and then we try to see where the track goes, which you can see almost through this board. Find a spot where the track goes. Let's say it goes to there, and then we solder one end of the new diode onto there, and let's say the other end of the diode goes to this resistor here. We solder the other end of the new diode onto there. I've chopped out both diodes. This one was probably good, but it doesn't matter. You can see I've got the two stubs of the original diode on there. I think I might be able to solder onto those with the new diode. The burnt out one is not so good. I've got quite a good little stub there, and not such a good one there. You have to be a bit careful, of course, soldering onto these, because this is only a little tiny bit of wire here. If you heat that up too much, they'll just come undone from the solder joint beneath, so it's a little bit tricky. I'm still humming and hawing about it. I think what I might do is just see how I get on. It's only a 5-minute job with tacking a diode in there, and if that goes swimmingly we might see if we can do something with this one. It's at least an hour and a half, possibly 2, to take the board out and put it back in again, so you're looking at a big bill for the customer if I have to do that. And also I don't like doing it because these ribbon cables here have to be flexed quite a bit to get the board out, and they are not very clever, these. It doesn't take much flexing for one of these to break, and you can get yourself into a fair bit of trouble there. I've taken the board out dozens of times, but it's never my favourite thing to do. So let's have a go from the top. If we can't make a neat job, we'll take the board out. Okay, it's fairly awkward to film this because I'm in between the camera and the board, but I'll give it a go at showing you what we're going to do. We're going to try replacing this diode here, and to do that I'm going to just make a little hook on each side of this diode and then attempt to hook it around the existing stubs there. So I'm just going to cut this off a bit shorter look, so that it's like that. And now I'll make a little hook with the pliers like this, and then the same on the other side. Just make a little hook like this. Make sure I get the diode the right way round. Of course, the bar is on the bottom, the bar is on the bottom. So let's see if we can hook this around the top and let gravity do the work for us. It's still not long enough, so I'm going to have to unmake it again. I think it's interesting sometimes to show you this real time. This is the kind of work that goes into these things. It's not all just a quick instant fix. So there you go, I've made it a little bit longer. See if we can hook that over this little piece of wire here. That's right, and that's now about right for the bottom piece too. There you go, you can see that in there, look, hopefully. And now I'm just going to crimp the two ends of the diode around that little bit of stub sticking up like that to make it mechanically secure. There we go. So that diode is actually in there, and all it needs to be done now is to solder. I'm going to do that with great care. I want to use as little heat as I can so that I don't melt the joint underneath and ruin that. So let's see if we can do that. Grab the soldering iron. Alright, let's see if we can get in there. This may not work, it's worth a try though. That's one. That's two. I'm happy with that one. Now onto the more difficult second diode. Okay, sorry I couldn't show you that second diode. It was very tricky to do and I had to get in there with my high-powered eyeglass, and I did just manage to bend that round the stub and bend that round the stub there and solder it on. There's the other one, which is a bit neater. I'll just clip off that piece of wire in a moment. Let's just do some tests now to make sure that we're okay. This should go to the blue, that side should go to the brown. Both of those should go to ground, so that should be short circuit there and also to ground. Let's see if that is the case. So I have the meter set to beep when I touch the probes together. This should be short circuit to here. It is, and also to ground. If I stick the probe on ground, then that is short circuit to ground. This, if you remember, should go to the brown. So let's see if it does. It does. And this, if you remember, should go to the blue. This is the output transformer, remember, primary. And that goes to the blue. So we've managed a rather tricky top side replacement of those two diodes. The next thing to do, of course, is to connect it all back together, and then without the valves in we should be able to power it up without it popping that fuse, because that's what it did before. Even without the valves in, we powered it up, it popped that fuse. Then we can gradually start to bring the amp up. We'll put the preamp tubes in, see what happens there. We'll put a new pair of EL84s in and see what happens there, because there might be some other damage that we don't know about. But fingers crossed that it will be just those two diodes. So let's do that now. Alright, moment of truth. I've soldered this wire back on. There's our two diodes that were soldered. Double check the bar is on the bottom. Yes, the bar is on the bottom. Everything else is back in. I've connected the power. Now this blue fuse immediately on turn on before, so let's see what happens. Oh, that's good. Power lamps come on. No fuse is blown. So that is stage one. Next thing to do is I think I'll pop the preamp valves back in and make sure everything's okay, and then we'll put a new pair of power valves in and see if it springs to life. There are the three preamp valves I've popped back in. Let's turn it on again. I didn't expect anything dramatic to happen, so I think they will just warm up nicely, and the problem wasn't down this end anyway, so we wouldn't expect any difficulty. Let me go and see if I can rustle up a pair of power valves and see if we can get some noise out of this amp. Well, I've got a couple of JJ EL84s here in stock, so I'm about to pop those in, but I just did want to say that we're not quite out of the woods yet. I'm hoping that when I put these in, this amp will all come to life and everything will be okay. But I'm prepared for that not to be the case, because something quite nasty has happened here on the amp. On the schematic here, if you remember, it's these diodes here, or at least one of them, that have gone spectacularly, kind of blown apart almost. So let's assume it was this diode here. For that to happen, notice this side of the diode is grounded, and this side would normally be positive by several hundred volts, because this is the HT here. This goes off, by the way, to the anode of one of the EL84s. So this is positive, and no current can flow through that diode because it's reverse biased. So for a lot of current to have flown through that diode, enough to actually kind of blow it apart, this point would have had to have gone a long way negative, now allowing current to flow down here to negative, if you like. And that would have happened with probably an output valve going faulty, probably crackling and arcing and causing all sorts of currents to flow through this primary and causing it to swing wildly up and down in voltage, causing this diode to fail. Okay, so fair enough, we've replaced the diodes, but we've had some very, very high voltages across this output transformer primary to cause that to fail. So has this arced inside? Has the output transformer failed? Are these resistors here okay? So we're not out of the woods yet. I'm hoping, fingers crossed, that everything will be okay with the output transformer and the amplifier will come to life. I'm going to bring it up gradually on the variac, so we'll see what happens. So I'll pop those output tubes in now, and we'll start to warm the amp up and see if we're good to go. Okay, back again. I've done a few little quick tests in the interim, and unfortunately, as expected, we're still in a world of trouble with this amp. Let me turn it on and show you what's going on. We actually do have a signal going through it. We can hear the guitar being played. I'll just strum that, but I can hear that's fairly distorted. And the problem we've got is this valve here seems to be fine. Okay, the bias is a little hot at the moment, but we've got 335 plate volts and 48 milliamps bias. I can adjust that down later on. But when I put the bias probe onto this valve, we are getting nothing on here whatsoever. And when I put the meter on the pins of this valve here, this one, we've got nothing. We've got no voltage whatsoever. The odd 1 or 2 volts on some of the pins, but we've got no HT, we've got no screen voltage. This valve's not drawing any current. Now that tells me a couple of interesting things. Here's the schematic again. Let me just see if I can show you here. Here's the slightly expanded schematic now, with showing the output valves. If you remember, here was our problem diode, and that goes off to the plate of this valve. There's our other diode that goes off to the plate of that valve. So we've got no voltage on the plate here. Well, that's just connected to the output transformer. There's B+, goes through that half of the winding off to the plate. We have got voltage on the blue here. That's that blue wire there. And the only thing between here and the plate is this ribbon cable here and some tracks on the board in there. So my first thought is that this diode took a lot of current, as you know, and it might have blown one of the tracks here leading to the plate. So I need to investigate that. However, there's another problem, because here are our screen resistors, R35 and R36, and this goes to Z voltage, which is just one stage down from the B+. It's actually on this capacitor here. So that voltage is present, but we're not getting any screen voltage. So that tells us that the screen resistor is also blown. So the screen resistor is probably open circuit. I'm not terribly surprised at that. That wouldn't normally be a problem. And we've got no voltage on the plate here, so we need to investigate what's happened to the track here. And we're also, unfortunately, now going to have to take out the power board, because all the resistors are on the underside of the power board and you can't get to any of them from the top side. And that means taking out all these screws. It's not a major job, maybe 5 minutes. But I think first of all what I want to do is to find out why we're not getting a connection from this diode here, probably just through one of the connections of this ribbon cable down to the power valve plate, because that's how it gets there. The diode's on the main board here, it goes through this ribbon cable and down to the EL84. So I'll have a quick look at that. I can't do that on camera really, and then I'll report back to you. I hope I don't have to take this board out to fix the track on the underside. Let's see what we can do. Okay, it's been about 10 minutes since I turned the camera off last, and I have discovered now why the HT is not getting from the, it's actually the brown wire, it's this side of things. The brown wire is not getting across to the plate of this EL84 valve here. And as expected, it's a broken track on the printed circuit board here. So this diode here should go to pin 3 of the valve, and when I go, this will be a short circuit. When I go down onto pin 3, there's nothing whatsoever. It goes down there on the third one in from the left, so in other words this wire here, and if I can just about get on the top of the ribbon cable there, and there's nothing. But if I go from pin 3 of the valve to the top of the ribbon cable here, you can see that that part of the circuit is correct. So once again I have a bit of a dilemma here. I don't really want to take this board out. We're looking at an extra £75 bill for the customer to take that board out and put it back in again. So I think I'm just going to solder a wire onto pin 3 and bring it up neatly along here and solder it onto there. That will save taking the board out, although of course we still do have to remove this board in order to change the screen resistors. Turning into quite a marathon this, I think you'll agree. Okay, very quick update. I've decided not to do the link from there to there. I could easily do it, but since I have to take this board out anyway, I can make a better and neater solder joint on the back of this ribbon cable with this orange wire, which I'm planning to bring up and solder onto that diode there. So I'm going to remove the board first. To do that, the first thing you have to do is take all the valves out. Just be a bit gentle with this, since just a little gentle steady pull and a little gentle circular rocking motion when you're removing a valve. And then we have to undo the screws that hold this board in, and there are 2, 4, 6, 8, 9 screws, which I'm going to get in there with a screwdriver and undo. I won't bore you with showing you that, but these will come out and then the board will swing out and we'll be able to see what's going on the underside. So you'll next see me when we have this board out. Okay, I've taken the screws out, 5-minute job really. Now I'm going to push up on the valve bases, look, and that allows us to swing the board out and clear. That's interesting. This is different to other Fender Blues Juniors I've seen. There are no resistors on this side of the board. The screen resistor must be up on this side of the board. Check the screen resistors, which I believe are these two 1K5s here, R33 and R34. Just have a look on the schematic, and it's actually R35 and R36. Okay, so it's this one here. It's 100 ohms. R35 and this one here, R35 and R36. So my guess is either one of those resistors has gone, or again we've got another track problem between here and here. So let's have a quick look. I'll put this on to lowish voltage, 2K at the moment. That should do. Short circuit will give me a short circuit, and I'll go on to this resistor. Interesting, that's open circuit, so R36 is open circuit, and just checking on the schematic, that is the resistor associated with the faulty valve. And here's our R35 here, 100 ohms, look. So we have an open circuit screen resistor here, which I can repair from the top side of the circuit just by putting another 100 ohm in parallel across that one. That will be fairly straightforward. I don't mind having taken the board out anyway. I can make a neater job now on the back of this board with our orange wire. So I'll do that now. I'll tack the orange wire on, and then we can put the board back. There we go. I've very gingerly bent the board back so that I can see the back of it. You don't want to be flexing these ribbons too much, and I've soldered this orange wire on here, and that's now going to go up behind here and end up on our board. So we can now put this board back. Again, handle these boards very carefully. You don't want to be swinging them around. These ribbon cables are quite delicate. I'll just show you how I do this. I'm just going to very carefully and gingerly put it back. Get the valve bases lined up. That comes through nicely. So all I now need to do is to put the screws back in. So I'll do that now. I'll just show you me putting a couple of the screws in. I've got one in there located, and we'll put another one. It's not terribly easy because you need exactly the right length screwdriver, which I don't actually have. There's another one in there. You need a Phillips or posi drive screwdriver like this, but with a shorter shaft. I've never found one. I've got this stubby. You can buy stubbies, but stubbies tend to be much bigger for bigger screws. So this one just about works with a bit of fiddling around. So we'll pop another screw in here, up underneath. There we go. They're going in quite nicely, really. I'll do the other three and then I'll rejoin you. Okay, all the screws went in nicely. The board's back in place. Here's the orange wire that we tacked on, and that is going to go to this diode here. It's a little bit long, so I'm just going to chop a little bit of that off there. Strip it back with the wire strippers. Give it a twist, and we'll tin the end. Like so, and then I'm just going to solder it onto here. There we go. Dress it in there a bit. The fact, it can go underneath that ribbon, look. And I think you'll agree, you'd hardly notice that was there. So that's quite a neat little repair. Of course, it's not ideal. Ideally, you'd want to take the whole board out, put these diodes in properly, find out how that track's broken and remake the track from the underside. But I think this is perfectly okay. It certainly won't cause any problems, and if anybody does take this board out at some future time, they might like to tidy that up. So all that remains for us to do now is to change this faulty screen resistor, this open circuit screen resistor. And to do that, I'm going to get another 100 ohm resistor and put it across there in parallel. So let me show you how I do that. Right, well, the technique here, you can just tin these leads here and tin the ends of these leads here and solder them on. That's perfectly okay, really. But it's slightly nicer if you're able to, as I am with this, to just lever the resistor out slightly to allow space underneath. And then we're just going to make some little J hooks on the end here so that we can get a slightly better mechanical joint on it. So let's see if we can do that now. So I'm just going to make some little J's like this. Now I'm going to see if I can hook this underneath the existing resistor. Yes, I'm able to do that. So you can see I've kind of hooked that round, and now I can make that drop the pliers, make that mechanically secure, and then solder it. So it's just a little bit of a better joint. I'll do that now. I can't do it live because it means me putting my head in the way like this, and it's not very exciting seeing the back of my head. So I will crimp those up with the pliers and solder them, and then we're ready for another switch on test to see if we can get any current through this faulty EL84. Right, you're seeing this as I'm seeing it. I've got both valves in. I haven't bothered with the preamp valves. We know this one's okay. I've got the probe now on this faulty side of things, and so we'll turn on. Hopefully we'll get some HT. We have, that's good. Now I'm watching for the current to gradually start to increase. It is, that's good. Just make sure it doesn't go too high. It's going up pretty quickly. Okay, that's looking good too, albeit it's too high and the amp needs rebiasing. Not easy to rebias these amps. I won't do it live on this video. I have done a video, I believe, on biasing the Fender Blues Junior. It involves swapping out some fixed resistors over here. So I think we're good to go there. I am just going to have a quick check of the screen voltage, but the fact that this is all ticking along nicely tells me we're good to go. I tell you what, why don't we just pop in some preamp valves and see if we can hear anything guitar wise. One, two, three. There is a way to bias these amps without using a bias meter, by the way. Again, I cover that on my other video. Okay, we'll turn on again and see if we can hear anything. Just take a few seconds to warm up. Okay, that's very distorted. Okay, still got a problem with this amp. Interesting. So everything's there, everything's working okay, but we have a lot of distortion on the amplifier. I'm just hoping and hoping that the output transformer hasn't blown. That would be a real shame. But that's very distorted. So we're still in trouble with this amp. Well friends, I have some very bad news for you, I'm afraid. I think the output transformer has also been taken out in this nightmare. Let me show you what I've found. You can measure on the output transformer quite easily. Here's the schematic here. So we have a blue, red and a brown. Red's the centre tap, brown goes to one EL84 plate, blue goes to the other EL84 plate. So obviously we can just measure with an ohm meter this part of the winding and this part of the winding. And when I did, I got about 80 ohms on this one and 10 ohms on this one. Immediate problem. I've disconnected this brown now. Here it is here, hanging in the air. This goes straight to the output transformer. And I can now go between red, which is the centre tap, and brown here, and we have 10 ohms on the meter, compared with onto the blue, other side of the winding, and we have 92 ohms. So, along with everything else we fixed on this amp, the output transformer is cooked. That's a real problem. Now fortunately I have one in stock from a cannibalized Blues Junior, so what I'm going to do now is I'm going to find that transformer, not quite sure where it is, and I'm just literally going to tack the primary onto here, here and here, and then we'll hang a speaker on the secondary and see if everything comes good, and that will obviously be a double check that it is the output transformer. So let me go and see if I can locate that now. Okay, I located the transformer. There it is, and you can see I've kind of jerry-rigged it in with some crop clips. I've gone from the brown onto where the brown used to go. I've gone from the centre tap to where the centre tap used to go, and I've gone from the blue by that green to the blue. I don't need to disconnect this blue because it's just one side of the output transformer, the existing one, and none of the other windings are connected, so that's perfectly okay to leave that. And we can now switch on, let it warm up a bit. I've got the output of the transformer connected to my house speaker by these crop clips, and there we go. Perfectly clean signal and no distortion. We have a cooked output transformer. So now I'm going to see if I can locate one. I might have to end up using this one if I can't find one. I've done a fairly quick search on the internet and can't find a transformer at a sensible price at the moment. I've put in an inquiry into Fender spares to see if they can find me one. Meanwhile, I'm going to drop the chassis out of this, which means taking out these two side screws, and the chassis will just come forward. I want to see how the transformer is held in on this side of the chassis. If it's a nut and a bolt as opposed to a nut and a captive bolt, then of course we're going to have to take the main board out to get the new transformer in. So I'll just have a quick look at that, and I might end up putting in this transformer I have on stock and then waiting for a replacement. So let's drop the chassis and see what's happening on the other side of it. Okay, I managed to get the chassis out. Of course there are two screws on the top as well and two on the side, and amazingly the chassis seems to be holding its position here. I'm not quite sure why, but anyway, I'm not going to mess around with it. I took this screw out here and I can see that they have actually threaded the chassis, so that's great. So I can take that one out. However, we're still not home and dry because the secondary here, which goes to the speaker, goes straight. There you go. Well, that's what happens if you don't secure things. I'm going to leave that in. The secondary here, this blue and black, comes out immediately under the printed circuit board. It comes out under there, and then wends its way down and emerges in a bundle here. So we are going to have to somehow thread those secondary wires down and hope to be able to hook them out from under the board. You can probably get my feeling. I'm trying not to take the board out of this thing. Such a major job. So I'm now going to undo the last screw on the mains transformer, sorry, the output transformer, put the new one in and see if we can thread those secondary wires through. I'm sure you're totally riveted to see what's going on here. I have removed the little rear jack board here. I couldn't get these spade terminals off. This is the secondary, of course, so I'm going to worry about that at some future point. I might solder onto here, and I've just chopped off the secondary, and I've come up with a neat little weave here. I'm going to solder a couple of wires to here, to each of these, you know, green and a black or whatever, and then when I pull this through, as I remove the transformer, those wires will pull through with it, and I can resolder on the new wires, or secondary wires, and pull those back through, hopefully underneath here, so that will save me trying to feed them down. The primary wires just come out right here through this grommet. Again, not particularly easy. It's just under the board there, so I'm hoping to be able to feed through the wires. But of course I've got these spade terminals on, so once again I might take a view. I might chop these off and resolder and re-sleeve to make my life easy, but we'll have a go at poking them through and see how we get on. Wish me luck. I thought I'd just quickly show you top side. So I attached a couple of blue wires to the secondary there, and that pulled through nicely as I removed the old transformer. I had soldered them to these two wires here, so I just pulled those through, and now I'm going to solder the new secondary. I'm going to remove these spade terminals. I'm going to solder those to those and pull them back through again. That will allow me to get the secondaries through. And the primaries I'm going to chop off these spade terminals and just pass them through the hole here, and then resolder it all at the other side. So I think that'll be fairly straightforward. Sorry, me again. I just thought you'd be interested to see the old output transformer. You can quite clearly see there that horrible black gunk that's come out of it, and when I smell that, it smells of lovely burning transformer windings. So this output transformer is definitely shot. There's a new output transformer in. I managed to poke the 3 primary leads down through there without any trouble whatsoever. Here are our secondary leads soldered to our little guide wires. So now I'm going to turn the amp upside down and, well, first of all I'm going to poke these down here, then I'm going to turn the amp upside down and pull those through from the other side. Well, that worked really brilliantly. There's our 2 guide wires there, which I just pulled through whilst pushing these green and black secondaries through from the other side, and here are our 3 primaries ready to have their solder tags reattached. Then we're good for another test. I'm quietly confident this time. A quick look at what I've done. So as you can see, I've put these terminal strips back on with a bit of heat shrink sleeving. They look quite neat, I think. And then I've put the secondaries back on again with a bit of heat shrink sleeving. So now I'm going to pop this little subboard back, connect all this up, and get the chassis back, which is not easy because once again it's the old Tolex problem. It gets caught behind. I had a great deal of difficulty getting it out, actually sliding it forward across this Tolex. It's a very tight fit, but at least it'll be easier going in than going out. So I'll put the chassis back in and then we'll have a little test. Well, here we are again. I'm getting bored with this amp now. I don't know what you must be like. I'm hoping it's going to work now. I've put everything back in. The chassis went in absolutely simply actually, so no problems there, no dramas. Put the subboard back in, connected up the HT leads and put the valves back in. I've got my bias meter on one of the valves. We know the bias is out anyway, so I'm just going to have to tweak that at the very end. Let's see how we get on. Moment of truth, got the guitar plugged in, turn on. Okay, good, we've got 360 volts. Current starting to be drawn through the amp, a nice reassuring hum from the amp. This is too high, that's 40. I'll have to look up what it should be. I don't think it's as high as this, but anyway. And oh, hooray! A nice undistorted loud sound coming from the amp. Reverb works okay, master's alright, middle, bass, treble, so we're good to go. All I have to do now is to bias the amp. I won't show you how to do that, I've done it on a separate video. I think I mentioned it involves trimming some of these fixed resistors. I'm just going to go to my computer and see what the correct bias is for that, and then I will adjust the bias, and that's job done. Okay, I've zoomed right in here just to show you I have soldered a 56k resistor across the R51 to reduce the value of R51, and that has brought the bias current right down. So we'll switch on now and zoom out on the camera, and we can see what the bias current's doing. It's coming up now, look, 5 milliamps, 6, 9 milliamps, 17, 18, 19, I'm looking for about 26, 25. It was running at about double the current it should have been running at. 23. That's absolutely fine. That's going to go up to 24, 25 eventually, and I'm happy with that. So that's job done. We have finished that. I will just quickly put the bias probe on the other power valve, just to make absolutely sure everything's okay on that side of the circuit. But I'm pretty confident because I can hear that the guitar sounds quite nice through it. Well, that was a real marathon, wasn't it? I got quite bored with working on this amp. I think I did 3 or 4 hours solid work on it to get through to finally changing that output transformer, and that fixed the very last fault on the amp. I think the customer was a bit unlucky here. This is a 3-year-old amp, it's not an old one, and to have one of the groove tubes go down like that in such a dramatic way, such that it caused those extreme voltage swings on the output transformer, which took out the diode, took out the screen resistor, took out a couple of tracks, and even in the final analysis took out the output transformer. But we managed to get it going again, and the customer, I phoned him, he's very happy. He gulped a little bit at the bill, but I kept it down for him because I put the second-hand output transformer in rather than spending £100 on a new one. And the amp's good to go, and it should be fine for a number of years now. So thanks for watching. I'll catch you on the next video.